https lewisray645otjrc.blog 2025 11 CAI Architecture, the Human AI Team Model Architecture for Safe Intelligence by Randolph A. Lewis, inventor of the patented Megahead system. The future of artificial intelligence will not be decided by how powerful machines become, but by how intelligently we design their relationships with us. The most dangerous aspect of current AI isn't its intelligence, it's its architecture. As billions of dollars flow into single centralized AI systems, we're repeating the same error that engineers and governments learned to avoid a century ago, building monolithic reactors of intelligence without safety valves, without modularity, without human integration. What we need is not weaker AI, but smarter architecture. The real path forward lies in distributed, team-based intelligence systems designed the way great organizations and resilient technologies have always operated. When Boeing builds flight controls, it doesn't trust one computer. It uses 3 that check each other's math before acting. Nuclear power plants employ multiple redundant layers of containment so that no single failure can lead to disaster. Banks separate authorization, execution, and verification to prevent corruption. These aren't arbitrary rules, they're survival strategies proven through decades of experience. With high-risk systems, safety arises from structure. What a system doesn't have, it cannot misuse. History's lesson is clear. Centralized power breeds fragility. Distributed responsibility builds resilience. The recent global outages of major AI platforms prove the point. When a single model handles everything, reasoning, memory, search, execution, one malfunction disables the world. These massive transformer networks process all tasks through the same neural pathways. They appear powerful, but are, by design, brittle. Performance data tells the same story. Even the best single model systems fail a majority of real-world tasks because they're overloaded, forced to juggle roles that should be separated. They reason, research, verify, and execute inside one opaque box with no internal oversight. When they err, there is no counterbalance, no independent process to say, wait, that's wrong. This is not an intelligence problem, it's an architectural one. While developing the patented Megahead system, a closed-loop hydrogen and water energy reactor that coordinates multiple physical subsystems, I discovered that managing energy and managing intelligence share the same principle. Safety comes from structured interdependence. Megaheads, power loops, turbines, and hydrogen cells each operate within defined limits, feeding data and energy to one another under human supervision. No single component can endanger the whole. I applied that same logic to AI design. The result is what I call the Human AI Team Model, a system built around specialized agents, clear boundaries, and continuous human oversight. Instead of one AI doing everything, each system takes a defined role. One gathers data, another analyzes it, a third verifies compliance or accuracy. Humans coordinate at the top layer, setting direction and resolving exceptions. Every action leaves a record, inputs, reasoning, and outputs, so that accountability isn't a mystery. This structure mirrors the world's most trusted organizations. Tasks are divided not for efficiency alone, but to prevent small errors from turning catastrophic. Separation of duties, information boundaries, and redundant verification transform AI obedience from a hazard into a safeguard. If one agent fails, the rest continue. If 2 agents disagree, the human executive intervenes. The architecture itself enforces balance. Engineers learned long ago that the safest systems are those that don't rely on perfect behavior. In nuclear design, control rods drop automatically by gravity if power fails. That's safety by physics, not policy. AI should follow the same principle. Instead of trying to train one massive system to behave perfectly, we build structural safeguards that make failure harmless. Each module can only perform within its limited scope. Research agents can't access payment systems. Creative agents can't rewrite security code. Safety is achieved by design, not by hope. Humans remain central, not as micromanagers but as coordinators. They occupy the executive layer, providing judgment, moral direction, and responsibility. The system obeys, but its obedience is channeled through architecture that guarantees accountability. This is the missing piece in modern AI safety debates. Oversight isn't a switch you add later, it's a layer you design from the start. Even simple experiments prove the advantage. When two different AI models were assigned complementary roles, one to research, the other to verify, the accuracy, depth, and reliability of their results increased dramatically. Each system caught the other's blind spots. What emerged wasn't competition, but collaboration. Scaled up, this principle becomes transformative. Multi-agent frameworks already outperform single models on complex industrial and financial tasks. Hospitals, banks, and infrastructure systems using distributed AI report major gains in both performance and safety. The pattern is consistent. Specialization plus coordination equals intelligence with integrity. As AI moves from experimental to essential infrastructure, its architecture must evolve. We cannot entrust the future to single entities operating beyond human comprehension. The way forward is clear. Build modular systems with well-defined boundaries. Require human coordination layers for all high-impact operations. Treat AI not as an oracle, but as a department, a capable team member whose power is multiplied through structure and supervision. These aren't limitations. They're enablers of scale. The same design logic that keeps nuclear plants stable and aircraft safe can keep AI aligned and reliable. The age of autonomous, all-knowing machines is a fantasy and a dangerous one. The age of coordinated intelligence, where humans and AI systems work as integrated teams, has already begun. The Megahead architecture proves the point in physical energy systems. The human-AI team model extends it to digital intelligence. Both rest on the same timeless truth that power without structure collapses, but structure turns power into progress. We don't need to fear intelligent machines. We need to build them wisely, distributed, accountable, and human-centered from the start. That is the future of safe intelligence. That is intelligence by design.